this lesson, we are going to recap some of the methods in which we've learned how to solve quadratic equations. Remember, when we say solving quadratic equations, we mean to find the solutions, or in other words, to find the roots, or the X-intercepts. We need to ask ourselves, what does it mean to solve a quadratic equation? Because there's a difference between solving a quadratic equation and maximizing or minimizing a quadratic. So in this case, we want to figure out what the X-intercepts are when we're asked to solve. We've learned 4 different ways in which we could solve a quadratic equation: completing the square, using a graphing calculator, factoring, or using a quadratic formula. Although using a graphing calculator would be ideal for most situations, sometimes we're limited to only using algebraic methods. And completing the square, although it will work, is often tedious. So we often prefer using factoring or using a quadratic formula to do it. So let's recap those 2 methods on how to factor and how to use a quadratic formula to solve quadratic equations. Solving quadratic equations by factoring is probably the easiest way to solve. But it's only easy if you remember how to factor. Mastering factoring takes a lot of practice, and you need to know your times tables. But if you can figure out simple steps like 2 numbers that multiply to this and add to this, then factoring is the way to go. So let's look at this example and recall the different methods in which we've learned how to factor. And then we'll integrate how to solve by factoring. First, let's start 2x squared minus 12x minus 14. The first type of factoring we always want to look for is common factoring. Notice how all 3 of these terms can be divided by 2, so we want to factor out a 2 from here. What's left over is x squared minus 6x minus 7. The difference when we solve is now we have this equals 0 on the other side. So we're going to keep that there until the very end. X squared minus 6x minus 7 is an example of a simple trinomial, which means we want to factor by using the sum product method. We need 2 numbers that multiply to -7 and add to -6. Quickly see if you can figure out what those 2 numbers are. Well, those 2 numbers were -7 and +1. So we're going to rewrite that trinomial as factored form by putting in those 2 missing numbers. So we had x subtract 7 and x plus 1. And of course, these were the 2 numbers that fit our sum product method. So this would be the factored form. But now that we're asked to solve by factoring, we now need to ask ourselves, well, what values of x would allow the left side to equal the right side? And the right side here is 0. Well, we have 3 different factors here: a 2, an x minus 7 in brackets, and an x plus 1 in brackets. And they're all multiplying with each other. Logically, we can say that the only way for the left side to equal 0, because that's what we want it to equal since the right side equals 0, is for any one of those 3 factors to equal 0. The only way numbers that are multiplying can equal 0 is if one of them equals 0. So first, looking at this 2, we can see that that 2 can never equal 0. It's always going to equal 2. So there's nothing we can do there. But what value of x would make this bracket equal to 0? Notice by inspection we can see that if x equals 7, then this bracket will equal 0. 7 minus 7 would equal 0. And it wouldn't matter what this bracket would equal. I mean, 7 plus 1 equals 8. But because we have this bracket equaling 0, then that means that this entire left side would equal 0 when we multiply everything together. So this is one solution for x, is if x equaled 7. Well, now let's look at this bracket. If x in this bracket equaled -1, notice how -1 plus 1 would equal 0, and thus the whole left side again would equal 0. So these 2 values for x are possible values which would make this entire left side equal 0. So we say that the solutions then are 7 and -1, or therefore x has to equal 7 or -1. And this is sort of easy to see by inspection. So if anytime you have a factored form like this and you can easily see the two values of x, they're always the opposite sign than what you see in the brackets. If you see x minus 7, you know that x will have to equal 7 for that bracket to equal 0. Here's another example we want to solve by factoring. 3x squared plus 8x equals negative 4. A simple rule to remember when solving is that we always want one side to equal 0. And in this case, we have one side equaling negative 4. That's easy to fix. Let's move that negative 4 over to the left side. So we have the 3x squared plus 8x. Moving the negative 4 to the left, it becomes positive. So plus 4 equals 0. Most students in this case would then look at this and say, this looks pretty tough to factor. It's not a simple trinomial, so I'm just going to use a quadratic formula. But remember, factoring is much easier to solve, way less steps, and you're less likely to make a mistake. So let's try to factor this as a complex trinomial using the method of decomposition. The steps to decomposition are similar to those in the simple trinomial method of sum product, but now instead we need two numbers that multiply to whatever the first and last numbers are multiplied together. So 3 times 4 is 12, so we need to find two numbers that multiply to 12 and then add to this middle term. So we want to add to positive 8. So two numbers that multiply to 12 and add to positive 8. Can you think of those two numbers? Well, those numbers are 6 and 2. So instead of writing two sets of brackets like we would for a simple trinomial, now what we do is we decompose this middle term, this 8x. So we're going to write out this 3x squared. We're going to write out this plus 4, which was the last term, equals 0. But now we're going to decompose this 8x into two things, which are the two numbers that we found here, 6 and 2. So we're going to decompose that into a positive 6x and a positive 2x. What this allows us to do now is to factor by grouping the first two terms and the last two terms. So the common factor out of here is a 3x, and we're left over with an x plus 2. And the common factor out of the second group here is a positive 2, and we're left with an x plus 2. We know that decomposition worked when these two sets of brackets here are the same. And our final step is to common factor those sets of brackets. So notice how this one big term and this one big term both contain an x plus 2. And what's remaining from each we put in brackets. So a 3x and a plus 2 from here. And now this is fully factored. So now we want to figure out what our solutions are. So remember, we want this bracket or this bracket to equal 0 because they're multiplying with each other. So if they equal 0, then that means the entire thing would equal 0. By inspection, this one's easy to see. For this bracket to equal 0, we would want x to equal negative 2. Negative 2 plus 2 is 0. This bracket's a little bit tougher to see by inspection. You'd have to do a little math in your head here to figure out what x would have to equal. So here's another way in which you could do it if it's tough to do in your head. Just write out what that bracket is, 3x plus 2, and set it equal to 0. This is what we want. We'll now rearrange. So we'll move the 2 over. We get 3x equals negative 2, and then divide both sides by 3, so we get x equal to negative 2 divided by 3, or negative 2/3. And that gives us our second solution for x. Remembering that when we say solution, that means x-intercepts, right, or roots. So this quadratic would have two roots, one at negative 2 and one at negative 2/3. Therefore, x equals those two things. So x equals negative 2 and negative 2/3. We wouldn't want to write that as a decimal, so leave it as a fraction. Factoring is one of the most important concepts you need to learn as a student. So if you struggle with factoring, make sure that you go over the factoring lessons we've learned before. Or ask a lot of questions on how to factor, or get some extra help, because you'll really need to know how to do it not only with this lesson, but in future lessons involving rational expressions and when you get into grade 12. It's super useful to know how to factor, and it's much quicker to solve quadratic equations. So what happens if we can't factor, or if the questions seem too hard to factor, like if they involve decimals or fractions? Well, we know we can use the backup plan of using the quadratic formula. Do you remember what the quadratic formula is? Pause the video and try to write it out. And here it is, the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and the entire thing is divided by 2a. These a, b, and c letters come from the positions of a quadratic equation written in standard form. A being the number in front of x squared, b being the number in front of the x, and c being the number by itself. These three examples on the left are all written in standard form, so we can read the a, b, and c values for each of them. So what I would like you to do is to pause the video and to try all three of these examples, and using the quadratic formula, find and solve the values of x. You'll see that all three of these different examples have different types of solutions. Some of them will be easier, some of them will be interesting. And one other thing to take note is I want you to leave your answers in exact form. If you remember in previous lessons we talked about how to simplify radical numbers. So if you end up with a radical number underneath a square root, like this square root of b squared minus 4ac, I want you to take that square root of number and simplify it as much as possible. Do not round your answers to decimal places. We want to leave it as an exact answer. Here is the beginning of the solution for question A. Notice how I wrote the a, b, and c values on the left, and then I always start my example by writing the quadratic formula first. Then I fill out all the things, all the letters, a, b, and c, into the equation, remembering to put them in brackets. That way, if there's negative or positives, we know exactly which things are supposed to be squared or not. Once everything's been put into brackets, we then solve or simplify or expand or whatever we need to do to get the numbers, and we get down to this answer at the end here. X equals negative 8 plus or minus the square root of 24 all over negative 4. Now in grade 10 you would have gone and left it like this as an exact answer, or you would have found an approximate answer by figuring out what the square root of 24 was and then figuring out your two solutions from there. But what we're going to do is we're going to simplify this radical number, the square root of 24, because we know how to do that. So let's do that right now. Find two numbers that multiply to 24 where one of them is a perfect square. And I think we can figure out that those two numbers are going to be 6 and 4, where 4 is the perfect square. So we have here negative 8 plus or minus, and now that square root of 24 is going to turn into the square root of 4 times the square root of 6, all over negative 4. And so let's change that root 4 into 2, because that's what that equals. So negative 8 plus or minus 2 root 6 all over negative 4. So that looks a lot better. That's now simplified. But we can, in fact, reduce this even further. In the numerator, we have a negative 8 and another term, 2 root 6. If we common factor in the numerator, we might get a number that can simplify or reduce with the denominator. And in fact, that's true. So we're actually going to factor out here. We have a negative 8 and we have a 2. We're going to factor out a negative 2. I decided to do a negative 2 because of the negative in front of the 8. I just want to make it positive. So negative 2 I'm going to factor out. What's left over here is positive 4. The plus minus won't change. It'll stay as a plus minus. And then when we take the 2 out of here, whether it's a negative 2 or a positive 2, the 2 will disappear, and we're just left with the root 6. And then all over negative 4. So now look what we can do. We can reduce this negative 2 and negative 4 by dividing a negative 2 from each, and we're just left with 2 here on the bottom. So we have this final answer where x will equal 4 plus or minus root 6 all over 2. And this is our exact answer. And in fact, it gives us two solutions. One solution that uses the plus sign, so 4 plus root 6 all divided by 2, and one solution that uses the minus sign, 4 minus root 6 all divided by 2. Do not fall into the trap of now canceling or reducing this 4 with this 2. Those cannot cancel. The reason being is that in order for this 2 to reduce, it would have to reduce with not only the 4, but also the root 6. And root 6 is an irrational number. It can't reduce or divide by 2 evenly. So this is as far as you would go. You can't go any further than this. Now let's note how many solutions we have here. There are 2 solutions for x. One solution uses the plus sign, one solution uses the minus sign. So let's write that down. There we go. Okay, let's look at example B. Alright, here's the solution to example B. 8x squared minus 11x plus 5 equals 0. Just a word of caution here when entering in your numbers. We have an interesting situation where our b value is negative. So don't forget in our quadratic formula when you have negative b, that means it's negative 11, or it ends up being positive 11. But in this question, that's almost irrelevant because if you notice the number underneath the square root sign, or our radicand here, is a negative number 39. And if you try to square root a negative 39 in your calculator, or any negative number, your calculator is going to give you an error. So why is this? Well, there's no possible number that if you squared it or multiplied it by itself would end up as a negative number. If you take a positive number and square it, it'll be positive. And if you take a negative number and multiply it by itself, it will also turn positive. So taking the square root of a negative number doesn't make any sense. We say there's no real roots. And no real roots is just the same thing as saying that we have no solutions. Now, why do we say that there are no real roots? Because in fact there are imaginary roots. There's a number system called the imaginary number system. And we don't quite delve into that in this course, but if you take a grade 12 calculus course, or once you get to first year university, you'll learn about imaginary numbers and how important they actually are in the study of mathematics. But for our sake right now, there's no real roots or no solutions. Essentially, this means that this is a parabola that has no x-intercepts. So what would that parabola look like? Could you pause the video and draw a quick sketch as to what a parabola could look like that has no x-intercepts? Well, here's an example. In this case, we know that our parabola will open upwards. We know that because our a value is positive, which means that in order for us to open upwards and have no x-intercepts, our vertex will have to be above the x-axis. So maybe it's right here. And if our parabola opens upwards, well, you can see that this parabola will never cross the x-axis. So this will have no real roots or no solutions. And our parabola will look like that. Okay, let's look at example C. Again, just like all of the examples, I'm writing the a, b, and c values out first and writing the quadratic formula out. Now, after we've plugged everything in and simplified, we get this weird thing that happens underneath the square root sign. We end up with 144 subtract 144, which is the square root of 0. Now, if you take the square root of 0 and put that in your calculator, you're going to end up with 0, because it's 0 times 0, which equals 0, so the square root of 0 has to be 0. Well, what does that mean for us? For us, it means that this plus or minus the square root of whatever basically disappears. We end up here with an x value that will only equal negative 12 and nothing left here because it's just 0 divided by negative 8. And simplifying negative 12 over negative 8, well, that gives us 3 over 2. So we have an answer for x, a solution, but there's only one solution for x. And unlike the other examples where we had two solutions or two roots, two x-intercepts, or no x-intercepts, this one has one solution. So what would a graph of this look like? Well, for a parabola to only have one solution, it means it can only cross the x-axis once. And since a parabola is basically a mirror image of itself, the only way it could cross once is if the vertex is on the x-axis. So our one solution, 3 over 2, let's say that's right around here, has to be the vertex. And so the remaining part of the parabola will now open up or down based on our a value. Our a value is a -4, so it's going to open downwards. So our parabola is going to look something like this. Of course, I'm not quite sure where it's going to cross the y-axis, but you understand the idea of the sketch. So this is really interesting now, because now we've had 3 different examples where we've had 2 solutions, no solutions, or 1 solution using the quadratic formula. And we can understand what the sketches look like. But my question is, if we were just given these equations and asked to figure out how many solutions existed, if we didn't care about what the solutions were, what's a quick and easy way to figure that out? It turns out that all of it has to do with what ends up happening underneath the radical sign. It's this square root b squared minus 4ac that decides whether there are 2 solutions, no solutions, or only 1 solution. We saw in example A that we had 2 solutions, and there happened to be a number inside the square root. And not just any number, it was a positive number, this positive root 24. When we had no solutions, the number underneath the square root was a negative. It basically broke our question or gave our calculator an error. So if that number underneath the square root was a negative, we had no solutions. And what about it for only the 1 solution? Well, notice how the number under the square root was a 0, basically eliminating the square root from the question and the plus minus portion and just giving us 1 solution. So that number underneath the square root is super important, and we have a name for it. We call it the discriminant. It's the b squared minus 4ac part underneath the square root. And that discriminant determines how many solutions we're going to have. If the discriminant, or b squared minus 4ac, is greater than 0, or a positive number, we'll have 2 solutions. If it's a negative answer, or less than 0, we'll have no real solutions. And if that number underneath the square root, that discriminant, is equal, and if the number underneath the square root, or the discriminant, equals 0, well, that means we're going to have 1 solution. We're going to see later on in this unit how using and knowing the discriminant, or figuring out how many solutions there are, will become pretty important to solving some other questions we're going to be given. But for now, remember the 4 different ways in which we can solve quadratic equations, knowing that factoring and using the quadratic formula are the 2 ones that we will mainly use. Factoring is the easiest if you know how to do it, but the quadratic formula can always be used to solve. Just make sure you don't make any careless mistakes.